I disguise the truth. I've been duck dog, getting to my new merch, colored duck sauce on the new couch with my chucks on. Get the on with that name. I'm big cool on the small check, cause I know now that I'm all that. Got a hot guy on the ball cat, get the out of my face. Talking to my mirror like I love you so much. Curving on my critics like I heard you, so what? You can kill my confidence, I think I'm the man. Tally all the I ever gave on my head. Lately I've been living like I can't take a loss. They ain't wanna help me, that's what made me a boss. You can't kill my confidence, I think I'm the man. We don't give a fuck, that's what they don't understand. Hey, one time like hey, look, niggas dying. Hey, one time like hey, look, dying from corona while I'm living on coronas. They've been living for attention, they've been dying for diplomas. My persona and aroma could've told you I don't give a signed a bigger contract so I could talk some bigger. Police pull you over, they be trying to give a I be such a gentleman, they came to see some. She just wanna cut, I wanna cut as in a bigger split. She ain't even ready for this wood I'm about to hit her with. Hit my swisher in your hitter in that order up. I was feeling low and then I realized I'm sorta up. Porter from the Porter, Florida, baby, let me pull you up.
Oh, let's see here. I think it's time. We can go ahead and click this.
Yeah, let's go. I'm unstoppable, do the impossible. I'm irresponsible, yet I'm phenomenal. I got an arsenal, I'm dropping bombs, you know. Who am I stopping, no? I'm really up, shit. To the top, here I go, think I'm chosen to be the king of rock, think the people are spoken. I can hear the tick-tock of the clock, I'm in motion. So now I'm gonna pop, causing all this commotion. Yeah. Sometimes I think that I'm unstoppable. Yeah. Ready to go, man, lock it low. That's right. I swear to God that I can drop it low. Yeah. I got a shot and I'm unstoppable. That's how I know that I'm unstoppable. That's how I know that I'm unstoppable. Yeah. Let's go. I don't care what they all say. I'ma do this thing my way. Been grinding hard on it all day. We work hard, then we all play. I'm addicted to the grind, man. So I refuse to waste time, man. One day it all will be fine, man. Gotta commit to the grind. You know we're back with the Guinness, setting records every minute, every track. In addition to the fact that we're winning, still we lack something's missing. Need a track that is hitting, making rap, making millions. I don't waste time, no, I make time. All these people wanna hate, fine, I'ma make mine. While you sitting there complaining, I'll be training. While you sitting there just waiting, I'm creating. Yeah. Sometimes I think that I'm unstoppable. Yeah. Ready to go, man, lock and low. That's right. I swear to God that I could drop it, bro. I got shot and I ain't stopping, no. That's how I know that I'm unstoppable. That's how I know that I'm unstoppable.
This actually monitors my heart for me. So I have an implant right here, and I put that on it, and it'll actually read it and send it to the hospital for me.
Hey,
What's up, Jay? You are live right now. Just be careful.
good.
We put some music on in the morning, get people moving and grooving.
Cool.
Got my it started off a really bad day today. So it was a long night of setting up the graphics for this, and then I got up this morning and man, I think I should have went back to bed.
That sounds like my morning too. Yeah. Things are just going crazy this Christmas rush, you know.
Yep. Second cup of coffee, second shot of Tully this morning.
Oh, there you go. Yeah. I'm looking at my first. But yeah, I just was on another phone call with a customer. There's just helping him get started this morning too.
That's awesome, man. That's awesome. Fantastic.
Yeah.
Just so you know, the format of the show, it is an open show. We can talk about anything you want. We got some people. I mean, I blasted this across so many groups last night. So we may get questions about, you know, I got a rash in this area. Can you prescribe a cream for me and stuff? All the way to this is what a 7-watt diode laser does.
Cool.
And anything in between, man.
Cool. Sounds good.
We got people popping in and out. So far, we've had upwards of like 6 people on this morning. And now we're at 3 consistents on Facebook and YouTube.
Cool.
So we'll bump up view wise. We'll have anywhere from 5 to 15 kind of commenters the steadily comment on the right hand side of the screen here.
Okay.
And then on replay, we're tracking between 500 and 1,000 views on the lives, just so you know.
Cool. I'm gonna close my office door so no one bugs us.
And don't hesitate. This is a live show. My base knows, like, we don't pull any punches. So if you got to take a phone call, you put your mic on mute up in the right hand corner of your screen. It'll mute you, and you can do your thing and come back. I'll fill the air until you come back.
No, it's fine.
And,
I think that's fine. It's only 7:54 here, so
yeah.
We don't officially open till 9. We take phone calls before that a lot of times, but I'll just mute it right now. Jen is in our she'll be here in a couple minutes. She's our office manager. She can handle the calls for the moment.
Right on.
Yeah.
So just topical type stuff. Oh, hold on.
Yeah.
I think that's our intro. Here it comes. When this stops, it's about to go down. We got John Galan on saying good morning.
Cool.
Justin McCutcheon popping in to say hi.
Cool.
We got Copperhead Mike. He's down in Florida. John's in Arkansas. We got Josh Ricker, is a local PA boy. So we're hitting the map already this morning. Have you watched any of the Coffee and Cuts?
Yeah, I think I watched one. I forgot exactly who it was, but a little while ago, probably one of them that you did in October.
Okay, so probably Rob Johnson was on.
Yeah, I think so.
Yep.
Cool.
Oh, we got Jacksonville, Florida in the house. Dustin is from Jacksonville, Florida. So when this music stops, I'll do our intro, and then we're going to be live to talk.
Cool.
Man, I hear this and I get jazzed up every morning. Let's see here. What do you think about the new live setup that I'm using with StreamYard?
Yeah, that's cool.
Yep.
Yeah, you're getting to know all the new technologies. That's good.
I'm trying, man. I'm trying everything.
That's cool. Yeah, there's so much new streaming stuff and YouTube and all this jazz. My 8-year-old son knows more about it than I do.
Right on. Here we go.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
All right, guys. Good morning. Good morning. Good morning. It's Croft CNC in the house. We have a special guest, Jay Johnson from Jtech Photonics. They are one of the premier laser companies for the hobby CNC machines. Kind of a worldwide name, known far and above, anything else. So, Jay, give us a little bit about your resume and about yourself, and then we're going to open up the floor for questions and kind of go from there.
Yeah, cool. Yeah, so I'm a laser nerd, geek, whatever. It's been forever. Built my first laser when I was like, I think around 7 or something. Went to school at University of California, San Diego, got a degree in laser engineering, optics and photonics. Went to work for a company called ESI, Electro Scientific Industries. We patented a bunch of laser processes using our laser equipment in semiconductor field. So everything that you have in your hand for your phone or your computer probably went through one of our machines that we made. We had a lot of patents on RAM and semiconductor processing, different materials and processes. Got bored of that, not bored of it, just got burned out, and went on a sailboat for 5 years. So kind of sailed around the world a little bit and got bored of that. And so I wanted to work a little bit and always wanted to start my own company. So got in around 2010, got a MakerBot 3D printer, one of the first ones made out of wood, and ended up putting a laser on it. The first thing I did on the 3D printer was put a laser on it. And that kind of started it. Wired magazine picked it up. A couple other places picked it up. And then I realized, oh man, I could, instead of just messing around, I can actually make a business out of this. So we started doing that and making instructions and selling lasers in 2011, I think. And it's just kind of grown from there. Adding all the new CNC machines, making higher and higher power lasers, and just kind of having fun with it and creating this community and helping out with all the open source projects and such. So it's just been a kind of a fun ride. So I think, sky's the limit on where we're going to go. I think this whole industry is that we kind of helped create a long time ago as part of the maker movement. Adding lasers to existing equipment is just in its infancy. So I think it's going to be a cool ride. So.
That's awesome. That's awesome. Do me one favor. Can you turn speakers down? We're getting some echoing.
Oh, gotcha.
You might have to put headphone or something on.
Gotcha. Yeah, wish I had headphones. All right.
There you go.
Yeah.
Good. So I guess I don't want to make this solely about Jtech because you guys compete in an area that you have a lot of not a lot of brands, but you have branding, and I really want you to talk on your expertise on diode lasers and stuff, and then as we progress into it, like, what are some of the perks of things that you have built? I want to make this more about you and your accomplishments and what questions the customers might want answers to, so when they're shopping, they know what to look for. Yeah. I don't want you guys to think that we're just shoehorning specific companies and stuff like that. We're getting industry leaders and industry experts in here to tell you what to look for. Yeah. And that's something that I think is lacking a lot. We make it more about the branding rather than the expertise. And for me, Jay, I've always called on you. As a matter of fact, our first talk, I think we talked at like 9 o'clock at night, my time. And yeah, your website said you were closed, and I was just doing something in my shop and had a question. So
yeah, I think that was around the same time, a few years ago, Christmas time. You were trying to get some ornaments done or something like that.
Yeah,
I kind of remember that. Yeah, my wife gets mad at me sometimes when I take calls like randomly, but I don't know. I just if somebody has a problem, then I just like to get it solved as quick as possible, because I know that customers are waiting for stuff, or their machine's down, or they're trying to get, especially around Christmas time. This is always a hectic time because everybody's trying to get their Christmas stuff done, which is cool. I mean, I think it's neat that everybody can make their own products with our lasers, and it enables them to do these cool things that they can make money, and especially during the holiday season. So
yeah, so I have had multiple lasers, and we've talked about this before. I've had multiple lasers, and I've had multiple of your company's lasers. I had the 2.8. I've had it was the 3.8, but it was actually the 4.2 kit.
yeah,
I currently have a 7-watt kit. Those things you brought up a really good point in. You guys are retrofitting the industry machines to have multiple machines on one frame. And to me, that's kind of where the industry is headed. Just because of people are moving the idea of manufacturing used to be 50,000 square feet warehouse, multiple machines lined up and everything like that. And in today's environment, I think we're moving more towards the guy in his one-car garage with one machine and just making multiple operations on it.
yeah.
And what do you think?
Yeah, I mean, I think that was one of the things when I first saw the 3D printers, going like, wow, this is going to revolutionize manufacturing, just because you can have this idea of personalized manufacturing. So you can have one guy with a 3D printer and a CNC machine and a couple other things cranking out actual real product. Or at least, a lot of times for 3D printing, a lot of prototyping and things like that. But you can still do a lot of stuff yourself. I think one of the things that I did at my old company was this idea of rapid prototyping, not waiting 3 months to get a circuit board in, or waiting 2 months to get a part manufactured. That has been drastically reduced. The time it takes to make a prototype has gone from months to minutes if you want, and that's because we have these industrial tools that maybe 15 years ago would have cost somebody $100,000. Now all of a sudden is within the grasp of the general populace, which is super cool. I think that it's funny that industry, a lot of the government entities can't even fathom this. It's like a lot of the regulations and such are for they're completely outdated because of the idea that it never was thought possible that Joe and Pat and everybody, all of us, could have a industrial machine in your garage that does actual real stuff. So it's just really cool. So
yeah, I actually, so I'm in a unique setup. I went from a small time garage setup to a multi-thousand square foot setup to an even larger multi-thousand square foot setup to now I sold off industrial machines and I'm back at home with I call them advanced hobby machines. They're stouter than the common hobby machines that you buy, but they're still not quite industrialized.
yeah.
So I call it advanced hobby, and I have 22 machines in 3,000 square feet. I've got 4 3D printers on a table. I've got vinyl cutting, and I've got 2 mills, 2 lathes, plasma tables. I've got 1, 2, 3, 4, 5. I've got 5 or 6 lasers. Routers, I've got 1, 2, 3, 4. I've got 4 router tables of varying sizes, and stuff like that. Like, and these are all machines that I can do multiple formats on. Like, the laser setups with the diode lasers, I don't have to have a full mirror setup and everything like that. To me, that's really awesome. I mean, I geek out on this stuff a lot because I just enjoy CNC machines. I tell friends, I have very few friends, but the ones that I have, I tell them, I'm like, I really don't like people. I like machines. I like playing with my machines because they do what I tell them to do. And if they mess up, it's not because they thought of it on their own. It's because I didn't program it right.
Yeah. Yeah.
You know, it's nothing when these guys are like, this machine has a mind of its own. I'm like, no, you didn't program it right.
Yeah.
It's your fault. Take responsibility for your screw up, you know, and to see those aspects, I geek out on it. And I really get excited about the industries coming together. You know, we have the hobbyist coming together with industrial manufacturing. We have router machines coming together with laser operations. We have, you know, there's just so many awesome things that are happening in our technology advancement that our kids don't even understand the lifetime that they're living in. And
Right.
It's awesome.
Yeah. Yeah. No, it's really cool about, I mean, sometimes you just watch the machines and just doing their job, and it's just so amazing what's going on. I love just sitting there watching the laser work and burning stuff. It's just really neat. So
yeah, and that I get mesmerized by my routers. The plasma machine, I like it because I'm a metal guy. But the routers, I get mesmerized by the sound, the movement, the motor whine. Like my plasma machine is servo and rack and pinion, so you don't really hear the servos at all. You just hear the clink 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 of the rack, you know.
yeah.
But the routers, being steppers, they have that zipping hum to them.
Yeah.
And I like that.
So
So
Dustin brings up a good point. He says that, you know, I think the idea of having limited shop space and having two machines in one, that helps so many people out. I mean, yeah.
It's I'm a little discouraged right now because I threw my hat into the ring. You have one of the Croft CNC impact engravers.
Yeah.
I really thought that was going to move a lot better, a lot faster than what it does, because it adds such another dimension to any machine. I mean, it's universal, almost like a laser system. And I'm really surprised that more people aren't working in the stone and engraving metal and stuff like that with these machines.
Yeah. Yeah. I mean, most people that I hear day to day are woodworkers. I think in the end, you know, a lot of people say, I just want something to put my logo on wood, and that this works out really well. And then they start doing cutting boards, and then they move into other things and realize, wow, I can make a lot of money with this, just engraving some of the wood products that I made. So I think in general, most people are looking at wood, and then they start getting into other stuff. I think stone is really, I think you're right. I think it's an overlooked area that could be really, really cool for people to do. I think they have a lot of cabinet makers and a lot of people doing home remodeling and stuff, and starting to buy CNC machines. Like old custom cabinet makers that do everything by hand are starting to realize, maybe I should get a CNC and do a little bit of other extra stuff with it. And then you start thinking about lasering on it, and I know a lot of home remodelers have they're starting to get into making custom tiles, which is pretty cool for backsplashes and stuff. I know that's kind of an untapped area, but I agree, the stone stuff hasn't been done as much. I think, you know, we have a backlog on videos, and that's certainly one of them that we were going to do, a hybrid video with your impact engraver and then adding laser to it as well on the machine. So certainly a lot of stuff we have to get to in terms of our YouTube stuff, our tutorials and things.
So that's a really good setup. So full disclosure, you guys sponsored me a 7-watt laser system.
Yeah.
And now it was one of the prototype first systems. Am I correct on that?
Yeah, a long time. It was years ago. Yeah. So yeah, it was one of our first 7-watt systems. Yeah.
Okay. So full disclosure out there, that way everybody knows. But you know,
you've also spent plenty of money with us too. So
well, people don't realize, like, I have a lot of people saying, why do these companies just give you stuff? Well, because I've also spent close to $1 million of my own money just buying machines and retrofitting them. Well, I didn't just go and say, hey, can you give me this?
Yeah. And well, as a business owner, I will say that, you know, people like you who actually use the equipment, and since you had 2 of our previous lasers, it's not a no-brainer to maybe, you know, give you a beta unit that you can put through the paces. And so we get something out of it too.
You want to have an early morning spine chiller?
What's that?
This is my 7-watt. Now it is in daily use. Okay.
Yeah. Nice. You know, you really refocus it so you could get the beam longer instead of taking the shroud off.
Well, one of the things was I had somebody here. I was teaching them how to do some stuff, and I was running through, and I just made a stupid mistake on pushing a button.
Yeah.
It came over, and I had a wooden spoil board down that had gotten moisture. So it had a bow, not a bow in the bottom, but the wood itself swelled in a spot. And as it was coming over the 1/8 inch, it hit it from the side. There was just an impact on the side. And because the steppers don't have feedback, it hit and impacted with the wood. And that's one of those things. That's completely my fault. You know, and that's what I try and tell people when you're doing this stuff. People make mistakes. Like on all my videos, I just go live. I don't edit videos, and I'm not like, oh, you know, we did this today and it came out perfect on the first shot. You know, I go live and I'm like, oh, that one skipped a step. That's not right. Let's take a look again.
Yeah.
You know, but I think a lot of the guys get confused on what they see on YouTube. Copperhead Mike just popped in and wants to know what the benefits of diode versus CO2. He has an 80-watt CO2.
Yeah. We get that question all the time.
Yeah. So I would like to preface what I think, and then we'll let the expert go down the rabbit hole. Okay. My experience is ease of convenience. That number one, out of everything, ease of convenience. I can have my router started up going. I have my offsets documented, and I hit a G28 or a G30 or a G54, G55, and I go from router to laser that quick. Whereas instead of routering something, taking it over to the epilogue, running that, you know, stuff like that. That's my take as a maker.
Yeah. And I think you're pretty much correct on that. I think that there's places for CO2 machines and diodes. I think that both of them have a place in my shop. We have 200-watt CO2 machines in our shop, and then we have, I think, seven CNC machines with lasers on them. I think what the benefit of having a diode laser on a CNC machine is just that. So after you're done carving, if you're doing a hybrid project and you want to put any lasering on something you already carved, it's already registered to your machine. I think that's one of the hardest things you can get done is trying to figure out how to register it to your machines, so the X and Y are exactly lined up. And if you have your laser and your router on the same machine, you don't have to touch your product to put laser on it. So it becomes super easy just to start and do lasering on top of something you've already engraved. The second benefit, I think, of the diode laser is that I know our CNC machines are all 3 foot by 3 foot or larger. Our CO2 machine that we spent $6,000 on is 19 inches by 22 inches. So we just can't do really big stuff on our CO2 machine. So we reserve that for the lasers, the diode lasers, to do really large projects. Our CO2 machine we use exclusively for cutting plastic. It just does a good job at cutting plastic. For anything else that we want to engrave, I find it easier to use the diode lasers, just because we have to turn down our CO2 laser to about 6% anyway, to get it to burn correctly. And so you're kind of at the same level. I don't think in engraving you get that much more speed out of the CO2 in a lot of cases. You do in some cases certainly, but not in a lot of cases with wood. So I don't know. Both have their place, but I agree. It's so much easier to do a project where you have carving and lasering on the same project, so where you don't have to move the piece.
So that's a segue into two of the questions that I have. The first one, what is the drawback, and what is the what is the biggest drawback, and what is a few drawbacks of the diode versus a dedicated CO2?
Yeah, I mean, the biggest drawback is power. I mean, it's just lower power. So I think that's the one big con of a diode laser. If you really want to cut something and just do mostly cutting, then diode lasers are not that great at it. It can cut things that are thin, like mother of pearl inlays for guitars, veneers, papers, cardboards, foams, things like that. But if you're like specifically want to cut 1/4 inch plywood, I mean, use the routing bit, or go get a CO2 laser. I mean, it's going to cut a lot better. I think that's the biggest drawback, is it's just not a super high power. But on the other hand, they're super easy to use. I mean, you can't throw a CO2 laser onto a large table. It needs to be enclosed. There's alignment mirrors. I mean, those tubes are like 5 feet long. Diode lasers have no high voltage, no water cooling, no alignment. They're 12 volts. It's super easy to put them on your machine. So, I mean, there's a lot of pros with it. I mean, and they're not that expensive either. If you start thinking about it, even a 7 watt at $725, it's not that bad for laser capability. There's other options out there that are cheaper, which, kind of lie about their powers and stuff. But yeah, so I mean, and Copperhead says the diode's slower than CO2. It's like in some cases, yeah, it's going to be a little bit slower than CO2,
Right.
especially with cutting. But with engraving, on average, a 7 watt can do around 80 to 100 inches per minute and come out with a decent clean burn. CO2 lasers might go a tad scotch faster than that, but
I was actually laser etching a photograph last night with the Jtech 7 watt. I was doing it in white pine. I was moving at 100 inches a minute, and it was a raster image programmed through. So I do my own photo cleanup first and dithering. And then I went to pick engrave to process it. And like I said, I was moving 100 inches a minute, variable power. I think I hit 100% power in a few spots. But for the most part, it was basically a variable power up to like 85%. And it took less than an hour. It was a 4.5 inch tall by 11 inch double photograph.
Yeah.
So, I don't think that that's too far fetched, especially if a machine is sitting dormant.
Yeah.
But you touched on something else, was different powers of diodes. What in your expert opinion, what is the highest powered diode? Because you see these different wattages. What are they measuring? Are they actually measuring the power going into the wood, or I'm kind of confused on that. And then there are a bunch of different add-ons to bring different laser beams together and stuff like that. So
Yeah. So I think, unfortunately, the Chinese, they tend to do whatever they want. And we have rules in America for truth in advertising, which they don't apparently have to abide by. So they're doing a disservice to the market in terms of confusing everybody. So what we have, our diodes are the highest power diode you possibly can get. There's actually only 3 companies that make this type of diode. This blue laser was developed by UC Santa Barbara and Cree, and also Nichia in 2005 or so, and they came up with the particular recipe how to make it on a semiconductor. And so it's only been around for a little while. So there's not many companies that actually have the process. Nichia has the patent on it, and they produce the highest powered diodes in the market, and they are harder to get, and they are more expensive, which is why our price is higher. But you've had your 7-watt for I don't know how many years and probably used the heck out of it, and it still runs. I think what happens is, yes, right. And we have the super high power diodes in our diode lasers, and we run them appropriately at the optical output power. So when you talk about optical output power, that is actual light. You measure the light coming out of it. And 7 watts is pretty much as high as you can get. That's it. For constant wave, just putting laser light out of a laser, that's as high as you can get. And that's what we're always getting the highest diodes and highest powers. When you start looking at these other Chinese lasers, what they're measuring is electrical input. So when they're saying it's a 20-watt laser, they're saying it's 12 volts and a couple watts. So, or a couple amps, I guess, like 2.5 amps times 12 volts. That gives you over 20 watts of input electrical current. So if you start doing that with ours, we run ours at that laser you have is 4 amps at 12 volts. So we're talking, it's over a 50-watt laser. No, it's not a 50-watt laser. It's nowhere compared to a 50-watt laser. If you talk about CO2 lasers, all talk about optical output power. That's all they've ever talked about, and that's what everybody's used to. And so this whole idea of now rating lasers as electrical input power is confusing everybody. So you buy from China a 20-watt laser, and it's really only a 2 or 3-watt laser, which unfortunately is manufactured, is probably the diode they're using is probably only rated for maybe half a watt of output power, or maybe 1 watt of output power, and then they overdrive it. So you can overdrive diodes by putting 3 times more current than you should into it, and for a short time you'll get more power out of it. But that short time could be anywhere from a week to a few months to maybe 6 months, and then the whole thing dies. And that's just kind of, so that's why they can get it cheaper, is because the diodes they're using are just not rated for the optical output power that they're doing. And then they're kind of lying about this other thing too. So you get a 20-watt laser from China, it's most likely going to be under 5. And every single one we bought in the beginning, we're like, wow, how did they get that 20 watts? And like, no, they didn't get it. You put it, and the real reason that no one in America really can kind of like in the marketplace can really test it is that the meters to test it cost around $6,000 in order to test optical output power from a laser. So we test every single one. We burn in every single laser that we have and make sure that the optical rated output power is what you're going to get when you get delivered your laser from us. So anyway,
right on. So that Dustin actually had a question about lifespan. Somebody replied 300 hours if you run it at 100% every job. Is this true? So I had my very first laser was a 2.8 watt, and I had that for about 6 months. And I can't tell you how long it lasted because I passed it on. The guy that used it after me used it for like 8 months, and then he passed it on, and the laser's still going. And that was 4 years ago.
Yeah, and it's probably still going. It's probably still going.
But like my 7-watt, I've had this one for 2 years. I use it. I use it religiously. I would say at least one project a day. I use it, and for 2 years, let's average it out. I maybe use it for a minimum of 7 hours a week. And most of them are between 60 and 100% power cycles, and it's still going strong like the day I got it.
Yeah.
You know, what's this 300 hours?
It's not from
How
us.
do you feel about that?
Yeah, no, it's not from us. I think, you know, it hits on an idea that if you run your laser at 100% and just only do cutting. So there's some people who use the lasers just to cut, and they cut it for 10 hours a day and nonstop, 100%, going slow, running at full bore. That's gonna deteriorate the laser faster than if you were just engraving pictures and stuff. Because when you're engraving photos or even doing logos, it's turning on and off, and it's just keeping the laser a little bit more thermally stable, just because it has some little time to not be running at 100% all the time. We have a customer who does that cutting and everything, and you know, he still gets thousands of hours of time out of his lasers. I would say that in general, we are conservative with our estimates, because when we put out a new product, we don't have a lot of the lifetime data before we put it out, and all the use data. And so we usually are conservative about telling people how long it's going to last. And I will say every time we've done that, it's lasts for years. Yeah, we have 2.8s that we started selling that in 2013 or 14, and they're still running strong. I think we've sold over a few thousand of the 7 watts, and we had a thing in the beginning, like, yeah, if it burns out, then we'll replace the diode for you. You know, we'll set you up and do it at cost. And out of thousands of them, no one brought their diode back to us. So I mean, and that's running strong for 2.5 years, maybe 3 years almost now. And so I think the lifetime is a lot longer than people have suspected it is. So
does air assist affect that at all? Because of the smoke getting on the lenses?
You know, I would say the number one thing that when I have people bring lasers back to get repaired, or they say, you know, I lost a lot of power, can you see what's going on? The first thing I do, I bring it in and I'm like, okay, let's check this out. I put it in front of the optical power meter. I'm like, wow, yeah, it did lose a lot of power. And then I take the lens off, look at the lens, and there is a rectangle burned right into the lens, and it's foggy. You can barely see through it. The number one thing that causes power loss in a laser is a dirty lens. And you can clean your lens after every project, or every 10 hours, or every 20 hours. The chances are that most people don't clean their lens at all ever. And after 2 years of heavy use, you're going to see a 20-30% decrease, because you have a dirty window right in the middle of it, and you can see that little rectangle in the lens.
So what he's talking about, guys, is the diode shoots through this lens right here. Now, this is a high resolution lens, and we could talk on that in a minute, but it shoots through, and what that actually magnifies it down to a point for you. Am I correct on that?
Yeah. It basically just kind of focuses it into a point. Yeah.
Okay. So what we have is the beam comes out through there, but then smoke actually comes back up into the area, the cavity around the diode, fogging the lens. And what's the proper way to clean that, Jay?
Yeah, the easiest way, I mean, there's the easiest and probably proper way is just to take a Q-tip, dip it in some isopropyl alcohol, shove it up there. Don't go super hard and like you're going to ram it, but just, you know, put the Q-tip in there, give it a couple twists, and then take it out and let it sit for 10 minutes to dry.
How often?
You know, as often as you want. I mean, at least every 10 to 20 hours. Like, you use it for a week. At the end of the week, just do that. The number one, the easier thing to do is maybe on your CNC machine, put a little fan next to it so you blow that smoke away from the laser. Or for ours, we actually take a shop vac with a charcoal filter inside the shop vac, and we zip tie that just to the gantry and suck the smoke away. And so it not only gets sucked away so it gets out of the lens, but it also scrubs it from our room that we're in. So it's pretty neat.
So I'll tell you guys my personal experience with diode lasers. I've had we're gonna list off a couple brands that I've personally had experience with. So I've had El Cheapo. I've had obviously Jtech. I've had Endurance. I've had I don't think the silver box one I had a 2.5 watt Chinese, but I don't think it had a name on it. It was just a little silver driver box. I think I got it off Banggood. So I have primarily had experience with diode lasers, and I can tell you myself, this laser is 2 years old. I cleaned the lens for the first time last week. But as Jay said, I have a box fan that sits at the back of my CNC, and whenever I'm lasering, I turn the box fan on to blow smoke out and away.
Yeah, that helps a lot. Yeah,
and I'm not the best at orange safety lenses. I would rather just wear the glasses you provide and leave the lens off so the smoke can actually escape. That's my personal. Do not do that. I'm not telling you to do that. I'm not giving you any advice to do that. What I'm telling you is that's what I do because I want to extract the smoke away.
Yeah. And someone's asking how much are the lenses? They're $19.99. They're $20. So I think, having a spare one is not a bad idea, especially if you're starting to see. I have a lot of people go like, man, I've been running the same file, or I ran a file a year and a half ago, and I just ran the file and it came out super light. Like, why is my laser dying? And I'm like, no, you probably should just change the lens. So I usually tell them, hey, go get a lens, and they get the lens. They're like, wow, that was it. And now it burns just as dark as it did a year and a half ago. So $20, it's not that big of a deal. We have a video on how to focus it. It's a little difficult to pop the lens out and get it back into perfect focus. It takes a little bit of time, but there's a video on how to do it. It's not rocket science. It just takes a little bit of effort to figure it out.
So I have a lot of people that message me. I do a lot of work in the background, guys. When like somebody has a problem with their diode, they usually private message me, hey, you do this, you do videos. Can you help me get it running, or can you tell me what's wrong? So what I find most of the time for me is I will recommend focusing the laser and then putting a dab of hot glue on it to hold that lens, because the vibration from the machine can make that lens come out of focus, correct?
Yeah, I mean, in general, it can. I think that the spring behind it, pushing against it, helps out a lot. I mean, I think we've gone to, in the last few years, we've gone to really, really more high tensile springs, which help with that. A little hot glue is not a bad deal. You can always put that on, but I don't think it's really necessary. But
do not put CA glue on there.
What's that?
Do not put CA
glue.
Oh,
no, that instantaneously ruins the lens. Yeah, if you want to ruin your laser, then yeah, put CA glue on there. No, don't ever put any. The fumes from CA glue are toxic to the AR coating on the lens, and you can watch as the CA glue goes on the lens or near the lens, you can watch it just crinkle up the coating on the outside of the lens. So
yeah, I made that mistake with a Chinese laser.
Yeah.
And luckily it was a Chinese laser.
Yeah, I made that mistake with about 20 lenses that the little thumb screw, because we were trying that little silver thumb screw, we were trying to get that to stay on because they were coming off, and we super glued about 30 lenses with it, and we're like, why do these lenses look like crap? Oh yeah, CA glue.
Gotcha.
Yeah.
So Dan this is a question I get the most. This is literally one of the setups that I get the most private message to me. What are your speeds and feeds?
Yeah.
Well,
I get that all the
there's
time
a
too.
lot to that.
Yeah. Yeah. I think we used to give out a little sheet with speeds and feeds, and we don't do that really anymore because it brought more questions than it brought answers, because every material is different. So if you give people exact feeds and speeds and it doesn't work out for somebody, then they're wondering what's the problem with the laser, and it really comes down to every material is a little different. I mean, even the pine you get in Texas is going to be different than you get in Pennsylvania. I mean, it's just all the woods are different. Everything's a little different. I mean, so that's why I always feel that you need to experiment a little bit with scrap pieces on your own, just get kind of your own process and then write it down yourself so that's specific for your particular material at that time in that area, and you have your settings the way you want it. I mean, you can always start with, like, for cutting leather. I mean, I don't do much leather work. I know cutting leather is a little difficult to get all the way through. I know a lot of people will score it and then cut it with a knife afterwards. I usually, when I try to cut, I usually run at 10 inches per minute is my pretty much optimal speed for cutting. And then I just figure out how many passes I do at 10 inches per minute. 1/8 inch leather might take maybe 3-4 passes. I'm not too sure.
So I posted, I cut leather all the time. It is faster for me to do a offset change and use my tangential knife. I have a Donic drag knife.
Yeah.
And I actually use that to cut the perimeter after I laser.
Yeah.
It's just so much faster.
Yeah.
And that goes to talk about some of the downfalls of diodes. They're not the end all be all. Like, people think they confuse CO2 with diode and the power output, and their expectations are through the roof. I'm going to be able to cut anything and everything, and I'm going to do tumblers, and I'm going to do vinyl, and I'm going to do this and that. And it's like, hold up, pump the brakes. You're putting higher expectations on something than what what it's capable of.
Yeah. Yeah, I think that's a common misperception. I think there's that adium, like, right tool for the job. I mean, your shop has a bunch of tools in it, and everything's going to have its strengths and weaknesses. And I think that's exactly right. Like with leather cutting, you don't use the laser to necessarily cut it all the way out. It's not going to be the fastest process. A knife will work a lot easier on that. With wood, like plywood cutting, it's like, use the router bit. That's why you have a router on it's right on your tool. Just use that. And I understand, right, if there's certain ones that you can't do with a router or whatever, and it's smaller, then use your laser. That's fine. But have the expectation that it's going to be a slow process if you don't use it for exactly what it's meant to be used for.
Right. So Dustin, let's see, we're getting really good questions here. It's coming through. You've answered a lot of them, and we've answered a lot going through. Sankar is from the Millwright group, the Mega V group, and he's talking about the baking powder spray. I know what he's talking about.
I do too, yeah.
So what I do to get good dark crisp carves when I don't have a lot of detail in them is I will use an actual baking soda mix, rub the wood down with it, and then laser etch, because it raises the fibers. The bicarbonate, actually, I feel it helps it burn darker and deeper. That's my opinion on it, and I have tangible proof that it does for me. I've been told that no, it doesn't do anything, but why do we use it in Lichtenberg burning if it doesn't?
Yeah,
you know what I'm saying? So
yeah, I think I've just heard about that one recently, and the cool thing about these diode lasers is that I think when we first came out with them, 9 years ago on CNC machines, we were the only ones doing it. And then, yeah, then you said that, and then the El Cheapo guys came out and did theirs, and then that moved into endurance. So it's in China is now selling thousands of them. So as more and more of these diode lasers get sold, more people are going to be using them, which means that more of this general knowledge and experimentation comes out, and these processes be developed. The baking soda thing, I think it works. There's proof from you and other people that say, yeah, spray a little bit of baking soda with water on it and go to town. I think that's a really cool idea, and I haven't tried it out myself, but I have the intern is going to do that this week. The other one, good example of another process that someone just figured out was that Nicky Norton tile process, the white ceramic tile. I would have never thought to spray white paint on a white tile and then burn it. I mean, that's a cool idea, and now everybody's doing those tiles. It's just neat. It's just cool that people are coming with all these ideas on how to make it better.
So one thing I can say about the baking soda or any of the wood additives that you put on, beware, it does different things to different species of wood. Your oak wood, if you put baking soda on it, will turn it like a green hue. So and it will darken up what's already there. So if you have a carve that's there and you want it to stay light, but you want to add in some lasering, do not add the baking soda. On top of that, the baking soda will smoke more. So make sure you have good ventilation and you get that smoke out of the way of the lens somehow, some way. But Sankar, thank you very much for the question. I'm glad we got some people in out of some different groups. Jay, a lot of people know me in the X-Carve arena, but we're trying to reach out to more and more groups to show them, like, just because I have an X-Carve doesn't mean the information isn't transferable. How do you feel about that application? Because you've taken a laser system and put it on multiple platforms and big platforms at that.
Yeah.
How do you feel about the sharing of knowledge amongst these guys, instead of saying, oh, I have this brand A and oh, well, I have brand B and brand B is better than A because of X, Y, and Z.
I think in general, all the machines do the same thing at the end of the day. So if you have a $20,000 Cam Master machine with a Jtech laser versus a $1,500 Generation 1 X-Carve, it does the same thing. I think it does the Cam Master do it a little bit more accurate? Yeah, maybe, but does it matter in most cases? No, probably not. If you're just going to be doing wood engraving, yeah, all of the processes, all of the information, all is pretty compatible with every machine that we upgrade. I think we have upgraded a total of 156 different machine types in terms of brand names, from 3D printers to CNC machines, and everyone's a little bit different. But in the end, you just need a controller to tell the laser to turn on and off at the right time, and move the X and Y in the right direction, and there you go. I mean, that's pretty much it. So.
See, this is why I love this show, because you just mentioned about softwares, and my next question was Gerbil, Mach 3, UC, CNC, all of those. You guys have a system of implementing these diode lasers to basically an on-off switch or a PWM switch.
Yeah, and I guess so. When you talk about different machines, I guess that is the one big difference in the machine types. The machines that use Mach 3 or UC and CNC or Win CNC, I know Cam Master and Shop Saver use Win CNC. Those, and then the Axiom uses the Rich Auto controller. and Laguna does too.
Real quick,
all those machine
hey, hold that thought.
Yeah.
Guys, if you do not have a pen and paper in front of you, get it in front of you. As you guys see, I'm writing down little notes as Jay's speaking just to know what we talked about here and what to put in my binders that we talked about before. Like I have those 3-ring binders, and our notes from this conversation will go in that binder so I can refer back to it. Don't hesitate to write stuff down, guys. Document. Okay.
Yeah.
Keep going.
So in those particular machines, the controllers that are non-GRBL, they are specifically designed for CNC, in which case we have to kind of hack it. And when I say hack it, you have to make either a general output or you have to splice onto the spindle output. So in Mach 3, you can make a general output. In Rich Auto, you can't. So what you are doing is just basically turning on and off the laser full power. A lot of them don't have power control, which means that you're going to be using feed rate to adjust your engraving depth. So if you want it darker, you go slower. If you want it faster, you go lighter, you will go faster. So faster is lighter, slower is darker. And that works out for a lot of things in terms of machines and just general engraving. The one thing you're going to get is possibly a little bit of overburn. Especially using like a lot of the Vectric products, you're gonna use it as it's like a CNC bit, but it's gonna be laser, so it's gonna be overlapping and things, and you're gonna get some where acceleration, where you're moving and you stop, the laser is still gonna be on full power, so you get a little bit of overburn and it's not consistent. I will say, if you have a GRBL machine, if you're looking for a diode laser and you're looking for a CNC router all in one, choose a GRBL based controller. Any of the Millwrights, any of the X-Carves, Shapeokos, any of those are all going to work really well for the laser. And that is because in the GRBL open source project, we branched it out. And another dude before us, he was working with us too a long time ago, geez, in 2011. We came up with the way to have the laser turn on and off and set power all on the same, I guess, parser as the CNC machine. So when you have an X and a Y coordinate, that gets sent to the buffer, which then moves the machine. Well, normally the spindle control is out of that process. And if you can put it in that process, then every cycle of the machine can turn on and off the laser at a particular power at the same time you're moving X and Y. What does that mean? It means that you can do photos. It means that you can put a pixel value at that particular location and not stop the machine. So it got forked a long time ago, I don't know, in 2012 or 13. And lately, Sonny from the GRBL project said, hey, let's merge the branch and let's put these two together so we have laser mode. And so what we did, and it's so great because back in the day, I think 5-6 years ago, you had to get our version of firmware loaded on your machine, and that was a pain because a lot of people don't really want to load new firmware on their machine. But so we've now it's in the main branch as 1.1. So during 1.1 on the main branch, if you have anything 1.1 or F or higher, then you're going to have laser mode, which means that you have the ability to do dynamic power control, which is super awesome. That means your laser will be adjusted. The power will be adjusted based on acceleration. So you never have overburn. You're going to have constant laser power all the time, no matter what you do in vectors. And you also have the ability to do nonstop photos. So you're not going to have to stop, change the power, move, stop, change the power. And so you can go and do a raster photo without having to upgrade your firmware like you used to have. So any machine that's a Shapeoko, X-Carve, Millwright, any GRBL machine with over 1.1F already has the firmware on it to run a laser, which is kind of cool. I think that the open source project for the software has really made this whole thing happen. I don't think if we had the laser mode on GRBL, we would have all these Chinese laser cutters. They all use it. Every single machine out there that's those cheap ones and everything, all this diode stuff isn't really possible without that GRBL software and that firmware in the controller that we helped make. And distribute on that open source project.
What is the purpose of a DAC board?
Oh, the DAC board, that's it's a hardware piece. So if you have it basically adjusts the laser power using step and direction from a controller. So all controllers have step and direction outputs for a particular axis. So if you have a 4th axis machine, like Mach 3 has up to 6, I think, like you can use the A axis output step and direction to use that to control the laser power. And the reason why we made that product is because Mach 3 can't adjust that spindle speed output fast enough to do pictures. Whereas the step and direction signals are part of that parser that gets updated at a higher clock frequency. So that if you use a step and direction output, then you can adjust a photo and make a photo. And so you have to use the PIC laser software that John Champlain came up with and Jeff Woodcock. And it's a good software where you actually adjust your Z height or your A axis height, so you can send it direction signal, step and direction signals. You basically send it movement signals to say what the value of a particular pixel is. And it's a little bit more complicated, but it's a way to get Mach 3 or any other machine to do picture engraving that doesn't have an output like the GRBL ones, where you can have it output really fast.
Okay, so that's what I wanted to make sure the fan base got, was that's a hardware solution to a software problem.
Yes.
And then Gerbil based or GRBL based is a mainstay software firmware solution to raster images.
Yeah.
Okay.
It's a hardware patch, I guess,
Yeah.
So it's a little bit more difficult to set up.
Okay, so Dustin from Jacksonville, Florida says, I use Lightburn and easel. Say I want to laser an image on a project, then switch over to a router image outline. What's the best process for importing image between softwares? And in what order do you recommend? Okay, this is one I get because I do laser and routering together. I do a lot of stuff where I utilize homing switches and offsets for setting up my projects. And then I basically write my vector paths in VCarve. And then any photo engraving, I use Pick Engrave. Now, that's not to say Pick Engrave is the end all be all. That's what I use. You guys have what is it? Laser Engrave in conjunction with Pick Engrave?
Well, we have Pick Laser, but we also really like Lightburn. For the GRBL machines, I think Lightburn is a really good all-in-one tool that's super easy for users to learn. I think it's
perfect. That's what I wanted to get at.
Yeah. And I think, that's a good question. When I do carving and lasering on the same project, I tend to do it all in Vectric. And then I send it with either Universal G-Code Sender or PIC Sender. The V-Transfer I've used as well, which is the Vectric Sender program. If you want to do an outline and you use Lightburn and easel, I would say I would probably do the outline first in easel. What I would take is the image, draw a box around the image and measure out what that box is. You can draw it then in easel or import it into easel. Carve the outline first and then find the center of that image and mark it and put the laser onto that center. Open the photo in Lightburn, mark your job origin as center and start from current position. Line that laser up to that center, start from current position, and then put the picture inside the outline. That's what I would probably do. That would be the process for me. But we get that a lot in terms of job origins and how do I find my origin. And I think, I think it's a little bit, that's one of the things that takes a little bit of time to learn on how to do it correctly.
It's taken me 27 years to understand offsets and origins and work offsets and machine offsets and everything like that. But once you start getting it, that's where the world opens up to you, because I'm one of those guys. I don't stick with Vectric product. I use the products that I know how to use fastest. So if I'm drawing something and I need to convert it to a vector, I actually use my vinyl cutting software, and then I export it as an SVG or a DXF into another product, and then write my code from that aspect. So my process is different from Jay's process because we came about the way we operate at different paths.
Yeah.
You actually have access to a lot more kind of like laser specific or CNC/laser software, and you come up using that. You're like, oh, I can do this much faster in Lightburn, whereas it may take me a little bit longer, but it's fast to me because that's what I know.
Yeah. Yeah. I think I like, I like using the Vectric products, and they're really good for a lot of things. The thing I sometimes do, so that's a good question too. So I think I like them both. To tell you the truth, Vectric is really good for the carving, and you can use our post processor for free and set your laser up as an end mill, and then use the quick engrave toolpath. That's super easy to do. If you buy their laser module for $50, you can on the GRBL side, that allows you to do pictures. I think it allows you to also have laser tools in the tool database. I like Vectric for doing multiple carve and laser projects all in the same one. But I will tell you, sometimes I design in Vectric and I'll import that as an SVG into Lightburn. And I like Lightburn because it has a lot more versatility in terms of your settings for your laser.
So on the screen, guys, I actually have my Vectric tool database, which I loaded to all the groups. And it has a power range from 20%, or actually down to 5%, up to 100% power. And then you can actually change the different feed speeds to do different things. And I have them listed out, some of them like lasering mirror, laser cutting wood, and stuff like that. Like I only laser cut balsa wood. So this is laser cutting wood is laser cutting balsa wood for me. But I have a ton of different tool settings. And then on top of it, I actually have a notepad, loose leaf papers with different settings for, like, I do my wife's felt gnome kits. And I have a setting for that that I implement whenever I generate code. I know what that is. Yeah. So once again, it goes back to that documentation. You've got to know your machines, you've got to know your softwares, and you've got to know the interface between the two of them. You got that section from keyboard to machine. That's a big question. That person sitting there controlling both of those, that's what's telling them what to do.
Yeah.
What do you have anything to add on that, Jay?
Yeah, I mean, I think you're right. And overall, the software side of things, there's a lot of different softwares out there. Just use what you want to use. I think some people have a process already that they use that with Vectric. Then just use Vectric if that's what you really want to do. I think I think overall Lightburn is designed for lasers, so it's going to have a little bit more laser specific stuff in it, which I think, right. There's a lot of cool stuff in it. I think it does a decent job with photos. The Vectric new photo laser module does a decent job. I think Lightburn maybe does a little bit better.
You actually let me use Lightburn, and I tried it, and for what it did, it was very good in my opinion. It was very good. The problem with it was, for me, the process was real cumbersome because I'm used to Pixender's dual profiles. I don't have to load and unload profiles, where my understanding was Lightburn, you have to have a profile for spindle, a profile for
No.
laser.
No. Now, on most machines, there's only 3 settings in, or actually 2 settings in the GRBL firmware that matter for a laser, and that's $30. That's your maximum spindle RPM or maximum laser power. We usually default now to 1,000, and $32, and that is the little piece of code that we put into GRBL that Sonny ported. Actually, Sonny did all the work. So hats off to Sonny. If you donate to the GRBL project, you can go to the GRBL GitHub website, and there's a little thing there to support the GRBL project. It's mostly Sonny. That's him. So he's done a stand-up job with GRBL and gets all the credit for it. The setting for $32 is laser mode, and if you have that equal to 1, then all that dynamic laser power and all the picture stuff goes and works. When it's set to 0, it goes back to the old. If you make a spindle change, it stops the machine. So really, if you just leave those, if you set those once, $32 equal 1 and $30 equals 1,000, you don't need to change anything to carve, because the only reason that you would ever need to change that is if you have an IoT relay controlling your spindle or your router,
which I do.
And you do. So, all right, but 90% or more of people do not have that, and so you don't need to mess with any profiles at all. If you do want to mess with it, then in Lightburn, on the console, there's a macro button, and we set up a button on there to say use laser, and you set $30 equal to 1,000, $32 equal to 1, and then you set up another macro as use CNC, and you set $30 as 1 and $32 as 0. And when you are done with Lightburn, you press use CNC, and when you come into Lightburn, you press use laser, and that's all you need to do. That's basically the same profile management that you have in PixSender, on a different platform.
Yeah, but that just goes to show that right there. I'm used to a certain way. I know that way. It's easy for me. And then the other way, now I have to sit back and I have to go, okay, do I want to give Lightburn a try again? Because now that I know how to do that, I can, maybe Lightburn is better for certain projects that I'm doing, guys. That's the big thing, is whatever you're comfortable with, there are 1,000 ways to skin a cat. Do what works. Don't go skin a cat. I'm not telling you to do that. So Bobby McBride here has a question that comes up quite a bit. There are a couple different things that could be going on with it, but his thing right now is, I'm getting a slight burn trail from what is burning to what's burning next. How do I stop that?
$32 equals 1.
There you go.
That's it. So the laser mode allows the laser to turn off during G0 rapid moves, and if you have it set to 0, it's not going to turn off because it thinks it's a spindle. If you have $32 equal to 1, it knows it's a laser and it turns off. So go into your console and type in $, and or in your MDI on PixSender, and look at your settings. Press that little GRBL button on PixSender, or in Lightburn, if you're using Lightburn, go in the console, just type in $32 equal 1, press enter, send it to the machine, and it will fix it.
There you go. That's your answer, Mr. McBride. McBride Woodworking, he does some awesome actual hand craftsmanship along with CNC stuff. And man, I wish I had the ability that some of these guys have by hand compared to what I do with CNC. Like, I can't cut a straight line with a circular saw to save my life. You know, but some of these guys like McBride Woodworking is phenomenal at building bed frames and curio cabinets and just fine craftsmanship in general. So I'm excited that he uses his CNC and his lasers to implement that into his hand woodworking, because he does some awesome stuff.
Oh yeah.
So this is John. John, I don't know how to say your last name. I would say it's Toft, but that's just me. But anyways, he mentioned Vectric trying to export the shade shadowing effect for laser. Jake, can you read into that? Do you know what he's trying to get at?
I think, are you trying to talk about the laser module where you have the 3D relief, possibly, that you can, I know in Vectric they have this, oh gosh, how to say the name. I think that there's this thing in the new laser module that was kind of cool that they put in, that Ed wrote. And it was basically, you can take a 3D profile and then put an image on top of it and burn the image on a 3D profile and kind of make the shading effect on a 3D profile. I personally haven't used it. I know it's something you can do. You have to use this. You have to use VTransfer or PixSender as your sender program, or you can run it in Lightburn, I guess, the output file. So the output file is going to be pretty big, and it's going to also have Z motion in it because you're going to be moving on a 3D relief. On our lasers, you probably have to refocus the laser a little bit under the shroud for that to be possible. You can go all the way up to 3 inches underneath the shroud if you want, so you can make a little bit more room so it doesn't hit anything. But I think that's what people are talking about. You can also just do shading if you want to do a 3D relief with shading. We did an Aztec calendar a few years ago for the Vectric user group, and we just ran the same exact toolpath file that we did with our VBit, but we just ran it through the post processor for the laser and didn't worry about the fact that there was a 1/4 inch or more depth in terms of the Aztec calendar where it was carved out. And we just ran it with the laser on it, and man, did it turn out cool. It shaded the whole thing. Didn't need to move Z at all, and it didn't matter that it was in and out of focus because it was just basically making a shade relief. And that's kind of a cool deal that you can do on a lot of your carves, is carve it first, get the wording and the letters, and then go over it with a laser, and it puts a nice dark kind of tinge to it and makes it look really cool without having to paint it. Another cool process.
So you mentioned focus height. You're telling me that I can take this 7 watt and move it up to 3 inches and focus it, and you're good to go?
Yeah. So it's set at the distance it's set at because that's kind of the optimal focus. But you can focus it from a longer distance, and you can probably do even more than 3 inches. I think at some point your beam is going to be a lot bigger. So what you're going to lose when you have it focused farther away is your spot size is going to get a little bit larger. So your resolution is going to be not as good. So if you're trying to do photo engraving and things like that, I would probably keep it closer. If you're going to do anything else that you want to have a giant pocket or something like that, and you need maybe an inch of space, then just focus it an inch or 2 away or 1.5 inches away. And your spot size might go from, instead of 0.006, it might go to up to 0.008 in terms of your line interval or your spot size, just because the focus is going to be a little bit longer and it's going to be a little bit bigger. We had a guy from the Park Service actually does stuff, has our lasers. And one of the things in Hawaii, this one dude did is for the hiking trails, he carved out of the local wood there the trail, 3D topographical map out of this log of where the mountain was. And then he took the laser and he drew in where the trail is and all the restrooms and things like that and all the details. And it's a mountain, so he had to have it focused pretty far away. And man, it turned out really cool. It was on the it was a magazine there. If you went to Hawaii on the Hawaiian Airlines anytime last year, you read his article about doing that project. It was kind of cool.
Right on. So you mentioned spot size. What are typical spot size and what affects spot size?
So spot size is the theoretical size of the beam. Your 7 watt laser, it's going to be a rectangle, so it's kind of like a projection of how it's affecting the material. the spot size also could be called the kerf, I guess, which is the distance of the width of the beam in terms of how it's affecting the wood. If you're burning in wood, the kerf is going to be bigger than if you're burning on metal, like anodized aluminum. You're going to see that spot not burn as much or take away the anodization as much, because on wood, it's kind of like causing a char effect. So on the 7 watt, with the high res lens, it's going to be somewhere around 0.007 on wood. Whereas on like doing plexiglass or something, I put it down to 0.0045. The new Pro laser that we just came out with has special optics inside the diode that takes the rectangle and makes it a square. So it takes the energy from the outside. So you have a rectangle on the outside. I don't know how to do a rectangle, but you have the rectangle, and then instead we fold in the sides of that rectangle and put it in the middle. So we take that energy from the outside of the rectangle and throw it into the center using a special optic. And we get 90% of that outside power into the center of the square, which doubles the power density. So we have this same average power, but we have almost double the power inside a smaller area. And that really causes the spot size to go down and be much better for cutting, and also for engraving too, because you have all that power in now a square, which then you can get that spot size down a little bit more. So on the new 7 watt Pro, the spot size is more like, instead of 0.007, it's more like 0.005 or so in effective spot size. So
that brings me to the next point: is what is normal percentage of power per upgrade in laser? So 2.8 watt to 3.8 watt or 4.2 watt. 4.2 watt to 7 watt. Is there a common percentage increase, or is it?
I think there is. You can kind of, I usually take it as if you have a project that is going to take you 3 hours to do on a 2.8, because it's running at like 45 inches per minute. You could do the same project in about an hour on the 4.2, because you're going to be running it at around like 65 inches per minute, which you can then do at about an hour on the 7, because you're going to be running it at more like 80 or 90 inches per minute. And now on the Pro, you're going to be running it at around 110 inches per minute. So each one gives you a little bit faster speed, which allows you to have a little bit time savings on your project. So if you have all the time in the world and you want to save a little bit of money, the 2.8 is a great laser. It's just going to take you a little longer to do than the 7. You just about double the time, because if you're running the 2.8 at 45 inches per minute and you're running the 7 at around 90, that's twice the speed. So you can get done with things twice as fast.
Okay, so there's about a 50% increase, right around 50% increase from 2.8 to 7 watt.
Yeah. I mean, it basically doubles the speed you can go.
Okay. What about, say, the 2.8 to 4.2? Is that about 25% increase then?
Yeah, I'd say. Okay. You can go around 45 to around, then you're mostly going to be around 60 inches per minute. So, yeah.
Okay, guys. So that right there, once again, these numbers are starters. These numbers are not set in stone. It's based on your machine, your laser power, the age of your laser, how fast your controller runs, how fast your motors run, how stable your machine is, everything like that. There's so many factors that go into this. We can't give you put this in and this is what it's going to do. You can't do that, because there's so many variables. But what we can do is start here and either move up or down based on output. That's the best we can give you. Am I correct, Jay? Yeah.
I think there's just a start place, and you got to just go from there. There's a library, and we're going to put a post out. There's a library we have for the 7 watt laser with light burn, and it has a bunch of starting positions to starting numbers, I guess, but you really have to do your own thing. We're going to have a couple scan tests. We have a scan pattern test, like a test card that we normally run on a scrap piece, and then it has all the feeds and speeds. It has goes from 50 to 150 and has little squares, and you can go in and see, oh, I really like that mid-level color. And I think that's important because everybody has a different perception about what they want it to look like. And I think my dark might not be the same as your dark. So when I say to go 80, you're like, oh, that's really too light or it's really too dark. It's like, now but that's what I think looks good on mine. It might, and that's a whole opinion about, what looks good.
Can I ask if you guys have a Vectric tool library available? Or,
I don't have one.
Make one available?
I'm not a huge Vectric user. I'm a Vectric developer, but not a Vectric user. As much as I am a Lightburn user, I think. So I have a Lightburn library, which I don't even really like giving out either, just because there are, again, people then go and say, oh, well, your setting wasn't that good for this particular thing. I'm like, yeah, I know. So it's just a start, just a start thing kind of a deal. But yeah, I don't really have a tool library for Vectric.
I'm wondering, I'm just wondering how we can get people into doing the sample test carve quickly and easily. How we might be able to best get people to understand, like, the power range. Everybody knows the circle with the power ranges and assigning them and everything like that. Do you have any good video tutorial out there on that or anything, or is that something maybe I should look at?
Well, we're gonna make one. I think it's been in we have all the video done. I just need to edit it. I'm sure if you've done a lot of videos, Chris, that it takes forever for every minute of video. It takes hours of editing. So we have a bunch with footage that we have that we just haven't edited together yet. But it's really gonna, at the end of the day, it's gonna have a toolpath file that you can run on any machine that has a test card that goes through and scans different powers and different speeds. And we have it available in Light. If you want to adjust the file, but if you just want to run it, it's just a G code. It's a little harder to do in Vectric to make that because you have to have all your tools. Like, your tool database looked like it was pretty sufficient to do it, but you have to basically take those and choose each vector and output with a post processor each one of those particular squares, and then line them all up in your toolpath tab, and then make them into one giant file. It's a little bit more cumbersome in Vectric to make the test card.
Yeah.
But if you just have the toolpath, you can just run the toolpath on any machine. Doesn't matter if you use Vectric or Lightburn or whatever. You can just run the toolpath. And so we're going to have that. We're going to come out with that soon. It's been a work in progress for like a year and a half. I mean, it's just we're so busy on getting product out. I mean, we hand make everything here in America, so we don't rely on overseas manufacturing for anything. So we're having, we were a fully integrated company here. So we make everything here and just spend a lot of time dealing with production and customer service that it's hard to get sometimes these cool side projects done,
Right. No, I completely understand that. Is my biggest thing is I just want to make sure these guys, it's Christmas time. I've got a lot of people asking questions. Hey, my wife bought me a laser for Christmas. How am I going to set this up? And just trying to figure out the best way to get these guys in and moving and understanding quickly. Yeah. So if there was a need for me to bridge that gap, I could start working on that quickly.
Cool.
Let's see. John wants to know, does job resolution in Vectric affect how the laser process works? I would assume he's talking about like the size of the closed vector and the kerf inside of that is what I'm assuming. I've ran into very few instances, and it's typically taking a line drawing to a vector where the laser has an issue. And it's not even the laser issue. It's actually the software issue says, hey, we can't process that because the kerf is too big. The tool is actually too big for that, but it's actually not. That's my experience with it.
Yeah, I think diameter and spot size and kerf width all have to be set appropriately so that the number one thing you want to have is you don't want to have little white lines between them. So you want to have it small enough that there's no white lines between your fill. And you want to have it large enough that you're not overlapping. Because I know a lot of people just leave it really small and they just overlap the heck out of it. And then they wonder why their projects are taking 10 hours to do. It's like, well, because you're running over the laser beam over and over and over and over again. You don't need to have your kerf width be 0.0002, you know. It's specific. You need to probably have it somewhere around 7 mil or so in order for it to be big enough that it's not going to take forever and be small enough that you're not going to have white lines. That's basically what you want in terms of resolution. In the end, you want to optimize your file so that you're not going to spend forever on it, but you also want to have it be small enough that you're going to have something that looks good.
All right. We're taking up a lot of Jay's time here. Jay, I'm going to ask you 2 more questions and we got to let you go. You got stuff you got to do.
Yeah.
What is your favorite Christmas movie?
Favorite Christmas movie? What's that one? I don't know. I like the one with Chevy Chase, the Christmas, the National Lampoon. Yeah, that was pretty funny.
Okay. What is one of your favorite Christmas memories?
I think when you're a kid, you just waking up and just can't even wait to get your presents. Like when you're, 6 years old or 7 years old and going like, that's the magical thing of like going to bed the night before, can't sleep because you're so excited about, morning presents and all that stuff. I think that's cool that I'm seeing that in my own son. Like, now that we have my son does that, he's around 8 and he just can't wait for Christmas. He just can't wait for it to come. He's like counting down the days. So I think that's kind of cool.
That's awesome. Well, Jay, thank you very much for your time. I want to let you go that way. I don't impede on your day too much, but man, there was so much good information in here. I want to thank you for your time. You gave us the most valuable thing you have. And we really appreciate that. And thank you for getting that information out to the guys. And hopefully we can see more stuff. The only thing that I ask is be safe, keep pumping out good product, and thank you for everything you do.
Yeah, thank you, Chris, for having me on, and I look forward to continuing all this stuff in the future.
Right
you're
on.
a great person for the community and helping everybody. I think that's known by everybody that you're a very valuable asset to everybody in these groups. So thank you for doing that.
Thank you very much, and get some lasers out. And if Santa packages something up to come to Croft CNC, I'll begrudgingly sign for it.
Sounds good. Hopefully Santa can bring you something.
You have gone above and beyond everything. Once again, full disclosure, Jay has given me a 7-watt laser, and I use and abuse it. As you could tell, that's the side of it. I have hours, hundreds of hours on this thing. So thank you for that. And man, you guys have a good one. Jay, have a good one and be safe.
All right. Sounds good. Thanks, guys.
All right. Later, guys.
Bye.